Okay. If X likes Blackpink, then he likes K-pop. Is this quantified statement? For all people, it holds that if the person like Blackpink, then she's like K-pop. Is this quantified statement? Let's see. Here say, if X like Blackpink, then like K-pop. He didn't say for all. That means it's not quantified statement. So we say BX to KX. If as condition they like Blackpink, then they will like K-pop, but not all people. Look here, for all people, this means it's quantified statement because there is at the beginning he said for all people is universal. It's hold that if the person like Blackpink, then she like K-pop. So here we have the condition. Same here, like see the same statement, but here add for all people. So this one is quantified statement, and we write it like this. Okay. If X is your classmate who has founded OpenAI, is this quantified statement? There is a person who is your classmate and the founder of OpenAI. Is one quantified statement. Look here, there is a person. That means there exists. Okay, here he told me that X is classmate and founded for OpenAI, so we use and, but it's not quantified statement. So classmate and founded OpenAI. Okay, here he said there is one person, at least one person, classmate and founder of OpenAI. So he write classmate and founder for OpenAI and add at least. There exists. So it's quantified statement, yes, because it's exists statement. Yeah. Okay. For each student with a smartphone uses social media. Is this correct or no? That means for all smartphone students they use social media or no? So the domain here is X. Every student have a smartphone. The function use social media or no? We need to check. The domain only if disclosure is fixed as student with a smartphone. So the domain here, students with a smartphone, according to for the statement. So what if the domain is disclosure is all student? Would be different. So here he didn't say for all students, he said for all students who have a smartphone. Okay, so here we go for something we call it rephrase or paraphrase, rephrase. If we see the condition here in example 12, we can rephrase it. So instead of every student with a smartphone uses social media, we can write if a student X has a smartphone, X uses social media. So here we paraphrase the statement because the domain here, every student have a smartphone. So we can say as condition to say it's correct function that have a smartphone. So we changed or make paraphrase the statement of the proposition. If a student X has a smartphone, then X uses social media. So SX, student X has a smartphone, this is the domain. MX condition, since X uses social media, so here as a condition, if the student have smartphone, then M. So here we can say is universal or for each student. Okay. All all SX is BX. So we can say universal or for each X, for every X. This is correct because we have all. No, SX is BX, that means for all X, this condition is not correct. Any student or any X cannot give me BX, will give me not BX or no BX. Okay, some X is BX, so here this is correct. Some BX is BX. At least we have one X, SX and BX. Some SX is not BX, so here we have not, that means the negation for BX. Okay. Consider BX is X like ice cream. So the function X like ice cream. So we can say everyone likes ice cream because at least we have one. For each X, BX. So everyone like the ice cream. The negation will be, it is not the case that everyone like ice cream. So here the statement everyone like ice cream, so I need to make the negation the inverse. So I would say not every is the case that not everyone like ice cream, so I will put not. There is different if I put the not here. Sorry, here I need to say not the case that everyone like ice cream. Okay, here mean there is at least one person that do not like the ice cream. Here the negation for this statement that everyone like ice cream is the case that not everyone like ice cream. So here is at least one person do not like ice cream. So we can say it's equivalent because the same meaning here. That's different if I put the negation here in this statement will not be equivalent, so I need to focus. Okay, consider B is a hottest publication, hottest politician. So exists here for at least I have X to be X. There is at least one hottest politics. Okay, here it is not the case that there is a hottest politician, so I can have the negation here. So equivalent for it, for all X there is no BX correct. That's why I told you, if we see the previous slide, here the negation here different from here. So we need to focus. The equivalent for this one is this one. So we need to focus when you use it for a proof. So we can generalize the De Morgan law to be as a law. We can use it for a proof after that. So here the negation, the equivalent statement. When is negation true? For every x, px is false. When false, there is an x for each px is true. And here same, the equivalent, because we already have the proof previously. There is an x for which px is false, px is true for every x. So if we say that all Malaysian like Titanic, we need to know the negation for it. All Malaysian, that's why we for each x, bx, that means the all Malaysian like Titanic. So if I need to have the negation, the first statement mean is not the case that all Malaysians like Titanic. If we use this one, at least one Malaysian do not like the Titanic. So here is not the case that all the Malaysian like Titanic. So I add the previous suffix. There is it is not the case that, and you continue with the statement you want. Here at least one, because we use there exist. So we need to focus. If I ask you to write what mean this symbols mean, so we need to focus. Let's say what's the negation for exist? There is x for x power 2 equal to is correct, or I need the negation for it. So here we have not here, then we have the function. So if I need to read it, we'll say not, at least there is one x, not cannot be x power 2 equal to, at least one cannot be. Or we can say for all x, not x power 2 equal to. Or I can see for all x power 2 not equivalent and not equal to 2. So I have three ways can have the negation for it. So show that not for each x, bx give qx is equivalent to there exists x, bx and not qx. I need to show the equivalent, so I need to use the proof. I need to approve it. We have here the left side, we start with it. So not all x, bx give qx. So here I can by De Morgan change it to exist x, bx, qx. Then I have here I can because negation and negation give the proof, the true, so I can have it like this. If I multiply, because this one can have it in the both side here, would it change for the or to not, or to and. So here we change the symbol from or to and have negation for both of P and Q, so we reach the right side. In many cases, we have more than one variable, require more than one quantifiers. For example, PXY, every author wrote some books. So QXY, if X equal Y. So here, every author wrote some books. Translate that for every author X, each author wrote his book Y. That means every author is the domain. The domain for us is authors, and the function author write book, some books. So at least maybe the one author have different books. So for all X, which is the domain author, we have at least Y. This Y founded by X and Y. Y is the book. At least we have one book from one author. So Y, at least one book for one author. Okay. There is a number X that retain Y when we multiply X with Y. So the domain here number, there is a number, that means there exists. He didn't say for all number, he said there is a number. That means I will use exist X. Sorry, I will use exist X because he didn't say for all number, he said for there is a number. So there is X for this is the domain that retain Y when we multiply X with Y. So we have for all Y, for all return Y, we should have X and Y. So here for all Y, I should have MXY. Clear? There is only one possible value for X is 1. So when I multiply will multiply for X should be 1, because any number I multiply it by the number will give me 1. So 5 multiply 1, 5. This is the point. Here 1 multiplied by 1 give me 1. Okay. The order of quantifier is important if the quantifiers are of different type. Yeah, this is correct. Here, the important to know which one is the first and which one is the second, because it's not equivalent or not equal. But here, because both of them same, for all X or Y, the same for all Y for all X. But here, because exist X for all Y is different for all Y exist X, there is different with meaning. We should be careful when we prove. Okay, for all X, all Y, BX, BY, BX is true for all pair X and Y. This is correct. When it's false, there is a pair of X and Y for which BX is false. For all X, at least Y, for every X there is a Y for which BY is true. So we need to clarify and be careful when we read and understand the meaning correctly, because maybe there will be correct and false question. There is an X such that BX is false for every Y, and usually we use them for proof. So